We have Bruce with us today, and Bruce Vance from Triangle area, the Research Triangle area of North Carolina. And we were comparing total dissolved solids in our water, in our tap water. And we have total dissolved solids of 94 here, Bruce.
And I've got a expensive water softener on my house, and I'm at 174.
So we're really fortunate here.
Yeah, we've got a well water. We've got very high total dissolved solids.
And we get our water from some type of aquifer here. I don't know the name of it, but it's very good water.
Yes.
So we're very lucky. Good.
Yeah, go ahead.
Okay, I'm going to go ahead and start.
Right.
On today's agenda, first we're going to define water, and we're going to talk about different ways to purify it, and then we're going to talk about who regulates deionized water, and then Bruce is going to give us really good insight about how he rolled it into using in his professional residential cleaning service.
Excuse me, can you guys see the presentation now?
Yes.
Thank you. So apologize for my incompetence.
Okay. I guess we can go back because we need to talk about the chat.
Okay.
If you have a question or a comment, please use the chat tool. And Cece always, an interesting or pertinent question comes up, she always breaks in and asks it for you during the presentation. And then we will have some time for questions at the end. And or else you can hold your questions to the end. So anything else, Cece?
No, that's it. I'll be watching chat.
Break up.
Okay, and then there were our glamour shots of me and Bruce. And then here's today's agenda, and I had gotten to making, storing, and testing DI water, the fourth agenda item, sustainability concerns, and then finding the right DI kit for your cleaning business. And here we have our universal solvent. The water molecule is has a positive and a negative charge, and it loves to bind with things. That's why it's called the universal solvent. It's polar. It likes both positive and negative atoms. And on the bottom, the image on the bottom is actually water molecules surrounding a sodium ion. It really loves ions, and it doesn't matter what they are. And if in the absence of these types of ions, it will bind to itself, and the image on the upper right is what pure water would look like, which is water molecules bound to itself with no extra ions in it.
So to get this right, this picture here in the middle is just a water molecule, and you take
a lonely water molecule.
And you take all the minerals and other inorganic matter out of it, and there's nothing for it to stick to itself, and it'll go to this state.
Right.
But it doesn't like being that way. It would rather have some dirt stuck in there.
Yes.
Okay.
Absolutely. Yeah.
Next one. Talking about tap water, our tap water is already full of dissolved solids, and that's because of water's polarity, which attracts so many other atoms and molecules to it. The way you measure these dissolved solids is, which is called TDS, total dissolved solids, is to use a TDS meter, and the US EPA measures it. It advises consumers against consuming water containing more than 500 parts per million of total dissolved solids. The average tap water in the United States contains approximately 350 parts per million. And I mentioned ours was 94 here, just out of our tap water. the US EPA considers anything over 1,000 as harmful to human health. These are some definitions. Hard water has a high mineral content, and it requires a lot of detergent and chelating agents in order for the person who's cleaning to clean effectively. And chelating agents are just agents that bind with metal ions and kind of sequester them out of the water so that they don't interfere with the water molecules themselves. Soft water have lower mineral content and require fewer chemicals to get clean while you're cleaning. And as Bruce mentioned, his TDS readings up where he is, what did you say, 175?
We run about 170 to 175 with a water softener.
With a water softener, so.
I don't know what it was before then. I mean, it's. And we can tell the difference. It's a heck of a lot easier to wash your hair or something with that softened water than it was before.
Obrigado, papai, pelo alimento. Te agradecemos, Senhor, pela refeição, provisão em nome de Jesus. Amém.
We have purified water. The definition of purified water is water that's been treated or rendered potable to neutralize but not necessarily remove contaminants considered harmful to humans or animals. It has very, very many uses, and it is produced in a range of purities. Some common purification methods are reverse osmosis, distillation, and deionization. Purified water is mechanically filtered or processed or basically cleaned for consumption or for a specific purpose. The top 3 types are the most common, and then the bottom 5, which includes carbon filtration, microfiltration, ultrafiltration, even some type of ultraviolet treatments and dialysis. They are often combined with distillation, deionization, and reverse osmosis in order to get really high purity of water, where the contaminants are measured in parts per billion or parts per trillion instead of parts per million. This is the purification process, where you see water on the left-hand side, water is heated to boiling. The water vapor or steam is captured and put into a clean container. That water is considered pure. It doesn't have, the steam itself kills any germs, and the inorganic minerals and ions are left behind, and it even removes some gases. And all of the other material is left in the original container where the boiling started. This is a discussion of the reverse osmosis purification. In order to understand reverse osmosis, unfortunately, you have to understand osmosis first, so bear with me. But we're all sitting here osmosing right as we speak. It's just a matter of moving water through a semi-permeable membrane from an area of higher solute concentration to lower concentration. And the image on the right shows the right side of the container has sugar water in it. The left side of the container is just plain water separated by a permeable membrane. And the water, the plain water side, is attracted, those molecules are attracted to the sugar molecules because they have a charge. And so they will pass through the membrane, and you will see the water level on the right side rise as the water itself tries to get some type of equilibrium so that each side is concentrated the same. With reverse osmosis, it's the same principle, but you're going the opposite way. And that way is you have a high concentration of salt in the water, and they're trying to get all that water to stay in one place and get the water to move over to the freshwater side, so they add pressure. And the most common application is the desalination of seawater.
That's your example here, but this could be any type of inorganic matter could be removed from the water this way.
Yes. Reverse osmosis is very wasteful. It may require 4 gallons of water to 1 gallon of filtered water. The larger the operation, the better the efficiency, but it still can be very wasteful. TDS reductions of 80 to 90%, which is why it's usually paired with 1 or 2 other types of purification methods. It will remove large organic components. There are some large bacteria, viruses, and fungi it can take out, but the smaller ones do get through. And so you do have some type of sanitation if it's going to be drinkable water. And again, it's usually put before the deionization part of the purification process if you're going to pair 2 processes.
Right. Well, you're using large quantities of DI water. They often do that to extend the life of the DI filters.
Yes. Now here's the purification by deionization, and this is what we're here to talk about today. You do remove ions from water. That's why it's called deionization. It's much like using a magnet, playing with magnets, where the positive end of one magnet's attracted to the negative end of another. You have usually 2 types of resins present in a DI filter. You have a negative resins and positive resins, and they both attract the opposite charge when the water is flushed through the filter. And so what you get out at the end is water that doesn't have anything to bind with but itself. So you get a very pure water, and you usually get readings. It's not uncommon to see readings of 0 to 5 parts per million. That's really what you want to see. Then you know it's pure.
And I guess it's our experience when you're measuring this, and we'll be talking about a little bit more about measuring total dissolved solids. You typically get a reading of 0 if everything's calibrated correctly and the filter is good.
But you can go up to 5. When you start seeing it creeping up, you know your filter probably is pooping out or getting full.
Pooping out? Okay. And when your filter gets full, the numbers will start spiking pretty sharply, pretty quickly.
So DI water, because all the ions are pulled out, it does not conduct electricity. And I don't know, did you do this experiment you were telling me about, or you just... Tom talks about an experiment where you have some deionized water in a bucket, and you drop a lit flashlight into the bucket and the light stays on. But the minute you throw in some salt, how much salt?
Just a pinch of salt, mix it up, and the electricity will conduct and the flashlight will short out.
So, you know, that's just an example of how DI water doesn't conduct electricity. In addition, it's very hungry or dirt craving, and it wants those other types of ions. It doesn't want to be bound only to itself. So this is the source of its cleaning advantage, and that's why it's so effective against organic soil. The filters do not remove organic components like germs, so there's always a chance that that's just kind of one reason you don't want to drink it. Not the main reason, but it might be.
You want to start with potable water. You want to use your tap water or water that you would drink. You would not want to put this up where you had really questionable water supplies.
But there's also the danger that if you don't maintain your filter properly, you could get some bacteria growing in it too.
Sure.
But also, DI filters vary in strength depending upon the need. We don't need the really super strong DI filters for what we do, and they're very expensive anyway. But the weaker the filter, usually the longer the filter life, and vice versa. And you can, and they do this in more scientific environments. They can run the DI filter through the water through the filter more than once to get it even more pure. And once a filter begins to fail, as Tom mentioned, the TDS levels rise exponentially. That's why it's important to test your water. The disadvantages of DI water is, despite what some people think, it is not a sanitizer. And as I mentioned, it might actually be a source of contamination if it's not monitored. Germs that are not filtered out may actually grow in the filter. And your storage container has to be clean too. It will corrode metals with prolonged exposure, and that's why copper pipes are not used with where a lot of DI water is being produced. And it is not drinkable water because of the lack of electrolytes. It can cause electrolyte disturbances in the blood. And, you know, when are you most likely to be tempted to drink DI water anyway? It's on a really hot day when you're sweating and really craving some water, and I think that's probably when you're...
Yeah. If you take a mouthful of DI water and swallow it, you won't really know the difference. They warn you for this. People who clean windows, for instance, use lots of this water, and you don't want to be out on a hot summer day just drinking it right out of the hose, because the more you drink, the thirstier you get.
Yeah.
Right. Okay.
These are some examples of its uses in industry. There are countless processes you can use it for. Here's a picture of it being used in a volumetric flask. It's being filled.
A what?
From a mounted, what did I say?
Volumetric flask?
What did I say?
No, you said volumetric flask.
This is a mounted DI unit in a laboratory. And here's some pharmaceutical and cosmetic examples. These are, it's used as a base in almost everything in a drugstore.
So these are cosmetics here?
Yeah.
Okay. Lens cleaner.
Lens cleaner. And here's an example of cleaning a circuit board using deionized water. It's used as a final rinse in a car wash for metal plating, and also there's a picture of cleaning solar panels with deionized water, in addition to windows. So who regulates DI water? I guess we start with tap water, because the FDA sets the standards for purification of bottled water. And the US EPA says that our tap water needs to meet the FDA's bottled water standards. So the EPA regulates the standards for tap water. That should be the same as for bottled water. And OSHA comes in. You have to stick OSHA in there, of course, because deionized water is used a lot in chemical processes and industrial processes. So it's often used around or in conjunction with hazardous chemicals. And OSHA regulates hazardous chemicals with either a physical hazard or a health hazard. So where does that leave us in terms of labeling? This is the standard that regulates deionized water in the OSHA Hazard Communication Standard. And it's really boring, and it's on our website, so I'll let you read it.
Not to say everything on our website is very boring. That's not true.
If you're so inclined, you can go to the website and read it. And so go ahead.
Yes, please. Moving right along.
But because I totally didn't get it, I called the South Carolina OSHA rep. And she sent me an email back, and I quoted her here. Though labeling is not required for containers of non-hazardous materials, e.g. deionized water, Listing the material identity on the container is recommended to avoid confusion among research and other personnel. So basically, they strongly recommend you label your DI water, and they don't really say anywhere how to label it, especially in the way we use it. I know that in laboratory and pharmacy conditions, they do have industry kind of, they do have a way to label the water that is very common in the industry, but they don't really say how we're supposed to do it, so we kind of took it upon ourselves to create a label.
We'll talk about that here in a bit.
And so we're going to let Bruce take over now.
Yeah, we seem to all be having a little bit of a problem with remnants of colds here. Very good, Janice. Thank you. We got very interested in the DI water. We had, of course, heard about it in window cleaning, and those of you who went to the ARCSI convention and the ISSA show in Chicago may have noticed that one of the window companies, Unger, was running a big demo with these big window cleaning poles, and that was all DI water they were using there. So it's something that's been in our industry before, and it's just nobody's thought about bringing it into the residential cleaning. So we decided, we played with it a little bit and said, this seems to be working pretty well. And we said, let's see what our staff thinks of it. And we're going to talk about how we introduced it, applications, training, the limitations of it, and it has limitations, and how it fits into chemical-free cleaning. So moving, okay, the first thing we did with our staff, we got them all together, and we took an area on a stove, and we cleaned part of it with our regular cleaner, and we cleaned part of it with this new cleaner that we were introducing, a new general-purpose cleaner, and checked it with an ATP meter and found out that the area with the new cleaner was much cleaner than the area with the old way we were doing it. Now, we didn't tell them what this new cleaner was because I didn't want the psychological effect of them going, oh, water? So we just said it's a non-toxic new green cleaner. We put on the labeling, since we did have to label it, we just said DiH2O. And we said, use this as our general cleaner. Get back to us in a week and tell us what you think of it. Well, they came back. They said, we love it. This is better than what we were using. What is it? And so what we did then is we got them all back together. And I did a little demo. I took a white plate and poured a little bit of coffee in it. And then I took a wet paper towel and I tried to soak up the coffee with a wet paper towel, and I said, okay, it's not working very well. This wet paper towel represents tap water as you get it out of the tap. It's already full of minerals and things. Then I took a dry paper towel, and of course you could wipe the coffee right out. That represents what we have here, which is DI water, extremely pure, no dissolved solids, an excellent polar solvent. And it was healthier. It is better for them than anything else we can use. Let's take a look at a couple of places you can actually use this effectively. Okay, stovetops. And this is very good, by the way, on your maintenance cleaning. It's not going to be useful in the fraternity house, but for a stovetop that's been cleaned every week or so, great. And use with a microfiber cloth. Now, many of you are using, we realize are using color-coded, and this is probably not the color you're using in the kitchen, but we figured this would show up better. It can be used on cabinets. Again, on that first-time clean, you may need your degreaser if there's a lot of grease on there. But after that, DI water and a microfiber will take care of it. Glass, wonderful for glass. It doesn't streak. It doesn't dry and leave mineral deposits behind. It's not going to take the built-up minerals deposits, if that's already on your glass. It's not going to take that off. But for maintaining the glass, it's wonderful. Yeah, go ahead. Chrome, excellent for shining chrome. Again, a glass tabletop. As with anything you're spraying, make sure you don't get it on the furniture. Don't overspray on the wood. Windows, and in this particular window, they have a film on it that is not supposed to have any chemicals used on it, so DI is perfect for that. Okay, what else do we have here? This is a polyurethane piece of furniture. I wouldn't use it on fine furniture directly. You could put a little bit on a cloth. On a granite countertop, fine. On marble, it's fine. We took a piece of marble, put some DI water on it, let it sit for 2 days to see if it was going to do any damage. No damage, and when it dried, it left no residue. So it just seems to be completely safe for marble or stone. Inside of a microwave oven, again, maintenance cleaning. If it's really heavily caked with grease, you may need a degreaser. But it's safe on the plastics. A lot of your degreasers that have delaminine in it can cause severe damage to that plastic. So you've got something that will work in almost every circumstance, is safe as far as we have been able to determine at this point on every surface we've tried it on. And anything that's polished, most anything you can use it on for light and maintenance cleaning. It must be used with a quality microfiber for best results. Think of this as a system. You don't want to, it's not as effective if you're using it with, say, cotton cloths. And we did some testing just visually on comparing a cotton cloth, a cheap microfiber, and a high-quality microfiber, and we noticed a significant difference with the high-quality microfiber. Things that it's not. It is not a degreaser. It's not a hard water scale remover. It is not particularly effective against non-waterable soluble soils. If you're looking at the chemistry part of that, it's good against with polar soils. It's not particularly good against non-polar soils. If it's a very light non-polar, your microfiber will get it, and this will help lubricate it. But if it's heavy caked on, you're going to need your degreaser. So if you have, for instance, if you had a stove which had a little bit of grease spatter, you spray it with this and you wipe it right up, no problem. If that grease was baked on, you'd probably need your degreaser.
And I guess we mentioned earlier, but we might want to mention here again, that is not really a sanitizer or disinfectant.
No, it's not. And I think, though, that you have to remember that 95% of sanitizing is cleaning. And most of the time when we're going out and we're saying we're disinfecting, we really aren't. We're not allowing for the dwell time. We're not allowing for proper cleaning beforehand, and we're just leaving toxic chemicals around. It is not a sanitizer. We're not. You can't say that it is, but you can say that you're sanitizing by cleaning.
Yeah, I guess the study we did back in the grade school earlier last year, we took ATP readings with a lot of different combinations, and we got a bigger delta in ATP readings with the deionized water and quality microfiber than we did when we were using sanitizers and disinfectants like the Clorox cleanup wipes, for instance.
Significantly better, yeah. Yes. Okay, so you want to think about bringing this into your company. How would you do it? Well, first of all, I would introduce it by setting it out like we did. Here's something new. This is getting a lot of attention throughout the industry. Tell us how you like it. Because if you say you have to give up your general purpose cleaning chemical and go to water, you're going to get a kickback. So let people try it out. It can be used, as I say, in place of your general purpose cleaner. How you're going to use it depends a little bit on how your current system is structured. If you're using, for instance, a what's really a degreaser, a pH 12 or something in that area, as your general purpose cleaner, this isn't going to be able to cover everything that it's covering. It will, however, do a number of things more safely than your general purpose cleaner is doing in that case. But if you're using something that's a reasonably neutral cleaner, this should be able to come in and just be substituted with no additional training. If you are currently using, again, high-quality microfibers. If you are using cotton, you're going to need to switch to the microfiber because that is an important part of the system. It will take some trial and error. You're going to find that there are some things it does superbly with, and you may find that there's some things it doesn't do as well. And one of the things we talk about in the class is that depending on where you are and what the soils in your area are, may define a little bit about how effective this is for you and over what types of soils. Things that it is not for use in the really dirty situations. We do not recommend it for the first-time clean on a fraternity house or the second-time clean on a fraternity house, if any of you have ever had to do that. This is not the one for the move-out clean that has problems, although we have used it in move-out cleans for many things, including windows. It is not particularly good on petroleum or petroleum-based soils because those are nonpolar. It is not a sanitizer, as we said, and it is better not to drink it.
As with most products that we clean with.
Yeah, that is, I was going to say, yeah, you know, we don't normally drink the ammonia or the bleach or any of that stuff either, so that's not a real big drawback. Okay. If you're doing chemical-free cleaning, this becomes your general cleaner. We were using the active ion before this. The teams like this a good bit better than the active ion. They think it does a better job. And you can use it whenever disinfection or heavy grease dissolving is not required. Those can be handled very well with the Ladybug and its tank system. That actually does a better job than about anything else out there can for most of those soils. So you've got this with that give a real good 1-2 punch. Okay, Tom, you want to talk about cost comparisons? Because that's another place. This is amazing.
Sure. Yeah. Thank you, Bruce. That was a great overview. Thank you for taking the time this afternoon and sharing with us your experiences with DI Water. I guess we were looking at a number of different alternatives, primarily as a replacement for the active ion. And as we mentioned earlier, we did a study back in a grade school earlier last year and learned a lot of interesting things. And Bruce really picked up on DI Water and aggressively started implementing it in his business and has had a lot of success with it. There's a lot of reasons why DI Water is worth giving serious consideration to putting to use in your business as general purpose cleaner. One, it does a really good job. Two is it's probably the most economical way of giving your staff a general purpose cleaner that actually works. This price comparison here, we took like 4 different alternatives, and you can kind of run your own numbers on any products you use and just boil it down to what are you paying for a quart of product. For the DI tubes that we're going to be showing you examples of and actually offering for sale through Modern Cleaning here in a little bit, there's a kit that we will be showing you, but I guess the key part of this kit is there are cartridges that you can replace and put in your DI tube. A lot of the DI kits that are out there or tubes are like disposable and the whole tube has to be replaced. Either that or it's part of a very expensive system that has carbon filters to take the chlorine out, and then the water's going through reverse osmosis tubes, and then it actually makes it through your DI resin, and those systems cost thousands of dollars. But the approach that we're taking here, you can get replacement cartridges for less than $60, and on the average, you should be able to get at least 300 gallons out of a cartridge. That will vary from one area to the country to the other. The harder your water is, the higher your TDS levels, the more quickly you'll have to replace the cartridge. But we think 300 is a reasonable, if not conservative, number. And you do the math, you're down to about 5 cents per quart. I went to HESCO, and you can, I guess, go anywhere, but it was just something online that's available to all of us, that the price per, I guess it's a gallon of the concentrate, that I think it's diluted 15 to 1 is $47, and you do the math, that equates to about 78 cents a quart. So that's, you know, I don't know, well over, as about 15 times as much, I guess, as what the DI would be. That doesn't include shipping either. Just for comparison purposes, we looked at the active ion, and the price for that was $369, and it came with a 2-year warranty. So we're assuming if you used it for the full 2 years, 5 days a week, and using a quart a day, that would all translate down to about 71 cents a quart. So the DI water is still quite a bit, again, to the magnitude of almost 1/15 as much as what the active ion would be. If anybody is buying ready-to-use product, and you can kind of pick your flavor, I just grabbed the Clorox Greenworks glass and surface cleaner, again, off of HESCO, but most of the RTU stuff is anywhere from $3 to $5 a quart. So, I mean, that's, you know, obviously a very expensive way to go. So at 5 cents a quart for the DI water, I think you're going to be hard-pressed to find a solution that, you know, is efficacious at all, especially one that works as well as this at such a low price point. So the DI water system, let's talk a little bit about how we can make DI water, how we store it, how we test it to make sure that the TDS levels are where we need them to be. What does that process look like? To the left here is a picture of the DI tube itself, and we have it opened. Coming out of the front of it is the actual replacement cartridge that goes inside of the tube. Off to your right is an example of the output tube coming out of the cartridge. And the way it works is you would take a hose, and we'll have some more pictures to show you, and hook up to the back end of the tube, and you hook it up to your regular hose bib, just a faucet, and you run water through the tube, and it comes out this end. As you see right here, here is a meter, and it is an inline constant read TDS meter, and that would actually be mounted to the side of the device if you were using it in production. And it will give you a constant read, and it should read 0 or 1, certainly less than 5. If that number starts going up, you know it's time to service the product and replace this replacement cartridge here. But the water feeds through the tube, goes through the output tube, and we're putting it in 5-gallon buddy jugs. And that way we can seal the jug and store it and fill our quart spray bottles up at our convenience. As long as you put it in a jug and you seal it, the TDS levels will stay near 0 for long periods of time. I can't tell you for how long. We've done it for several months, and I've seen no shift in the TDS level. If you leave it in an open container, if you pour it in a bucket and leave it out in the open, the water will actually start absorbing minerals from the air itself, and the TDS level will creep up. So after you make the water, you'll want to store it in a container such as this that's got a spigot and a lid on it that you can seal it and keep it away from the open air. Again, here's a picture of the buddy jug. Here's a picture of what the jug looks like, and we have a DI water label on this, and off to the right are instructions, precautions, explaining what it is, how to use it, and what to do and not to do with it.
One of the things we've been doing is to flush it out every week and flush out the bottles just to prevent the possibility of things starting to grow in there and have water getting stagnant. I don't know if that's totally necessary, but that's a
no, that's necessary.
Yeah, we've learned that. I guess that was one of the things that we learned with active ion. If you let water stand in it day after day after day, eventually you'll start getting microbials growing in the water, and I guess it's like a fish tank or anything else. You just don't want the same water standing there for long periods of time.
Yeah, this is cheap enough that it's certainly, you're not wasting a lot if you pour out a little bit and rinse your containers out.
So the tube that we looked at earlier has a TDS meter in it that will read, constantly as you're using it, but it's also a good idea to have a standalone handheld TDS meter. And here's an example of the one that is included in the kit. And you just take some of the water after you've run it through the tube, or if it's in the buddy jug, you can pour it in the buddy jug and put it in, and you'll get a reading. This has a reading of 94. So what we're doing is looking at a glass of tap water here. If this was water that had gone through the DI tube, it would be reading 0. And I guess the use of this is fairly simple. You just push the button, stick it in water for a couple of seconds, and it'll pop up and give you a reading. It's a fairly simple piece of equipment to use.
I'm just going to go through this real fast. Since we're real close, I want to get to questions. TDS meters, this is kind of how they work, but basically what they do is they measure the electrical conductivity of the ions in the water, and they do a conversion factor and tell you the total dissolved solids. So, and that's basically it. So we can move on.
Very good.
To the next.
And if you got it any more detail, it'd be boring. We've already, I guess, established that we don't want to do that.
Geek alert. Go ahead, move forward.
That's it. Okay.
Let's talk about sustainability. The resin inside the filters or the cartridges, they are organic. They are from natural sources. The resin comes from the Oriental sweet gum, or that's one of the sources. They're making it synthetically now, but there are some from organic sources. You also find it's called styrene. There's a fancy name for it. It's also found in a lot of foods. It's a lot in cinnamon, beer, beef, coffee beans, strawberries, peanuts, and wheat. So we're not strangers to styrene. So it is organic. It is recyclable, but we'll talk about that a little more. The advantage to DI water is you only make what you need. You can do it that way, or you can do it like we do, and we make a bunch of it and store it, and people just come up and fill their water bottles from our buddy jugs. There's no expiration date on it, really, and you can test it with your handheld TDS meter. There's a reduced transportation. There's no reorders or delivery involved, really, and reduced electrical loads because you don't use any electricity to produce it in your own office. Some of the disadvantages, there's a lot of conflicting evidence as to whether the styrene resin is, in the amounts we're using it now, is harmful to humans. So, it's hard to say. I really don't know. The OSHA and the EPA and a lot of different people are doing studies on it now. But it's not classified as hazardous at this time. And this next point, currently no plans to develop styrene recycling process in the United States. I was trolling the internet, and I found before the webinar I did find some new information. They do it a lot in Europe, especially France, and they are recycling it in LA too. Styrene makes foam cups and takeout containers that we all know and love from when we go out to eat.
Styrofoam, it's all. Okay.
Right, and it's also used in automobile body parts and boat hulls, vehicle tires. That was originally what they used those sweet gum trees for, rubber during World War II. It's hard plastic food containers used in food services and carpet backing. So they're more and more things that it's used in, and so they're looking for ways to recycle it.
So we take our leftover cartridges and we can ship them to France or California?
Right.
Is that what you're telling me?
Well,
okay.
Unfortunately, the only option right now, unless you're in LA or Europe, is to pitch them into the landfill. But they're doing more, and they're being recycled into those packing peanuts and
I'm glad we skipped over the boring stuff.
I thought that was interesting.
That being said, Stacey, can we open it up for questions?
We sure can, and we've got quite a few already that I'm going to start with. But I'm going to throw you guys a humdinger right off the bat. You're going to love me for this, right? So Dieter asks, how does the DI system compare with liquid ozone? He received a recommendation from a colleague in the industry to look into liquid ozone, and I know that you guys have worked with that option and currently offer it through Modern Cleaning, so I think you're going to have a really good answer.
Sure. I mean, the Tersano product, Lotus Pro, is liquid ozone 03. I guess comparing and contrasting, probably the biggest difference is the 03 is a sanitizer. It's designed primarily for, say, kitchen counters and surfaces where reducing the germ load is something that would be important.
And that you need to know for sure that it is sanitized, that you need assurance that it's sanitized. So,
I mean, speaking like in our own house, for instance, in the kitchen, we use DI water all over the place, but like on our kitchen counters, we will use, the Ladybug if we're cleaning for real, but if we're like in a hurry, we'll just take the 03 and spray it and feel comfortable.
That's my go-to for everyday use.
Yeah, the other thing to remember is the 03 is only effective as a sanitizer for a limited amount of time and as a cleaner for a limited amount of time, so that it does have to be continually recharged, where the DI does not.
Exactly, and it is something, there is the cost of the equipment and you have to replace the ozone filters too.
Yeah, I mean, in retrospect, we could have done a cost per quart on the 03. Maybe we'll do that after this, but the cost per quart on that is a fair amount higher than what the DI would be. The DI, just for general purpose cleaning, is more than adequate and certainly the most economical, the sweet spot from a value standpoint, cost and benefit.
Okay. We've got a set of questions from Wells. He's concerned about the difference between TDS and bacteria in the water. He understands the TDS meter working, but he's concerned about bacteria left in the water. How can you measure the bacteria in the water? What are appropriate levels of bacteria in the water before it's too much or even too little? Is that something that you guys have looked into?
Didn't necessarily look into it, but I assume in our business that if we are monitoring the TDS of the water that comes out of our filters, and if we are disposing of them in a timely manner, we're okay in terms of not having bacteria grow in our filters. You do, as Bruce says, his practice is to clean out the buddy jugs and the sprayers. Occasionally, that's a really good idea, keep bacteria from growing in them. And if you're going to measure bacteria in the water, I think you really need a relationship with a laboratory.
Well, but, you know, we do use ATP meters, and we will measure the soil load on a surface after we clean, so that's one way that we can satisfy ourselves that we're not leaving any organic matter there that would be, you know, at a level where it would be a concern. And actually, you know, we haven't talked about this yet, but we'll be doing a webinar here before too long where we'll be demonstrating how you use a TDS meter to measure the soil load in liquids. Actually, there's two different swabs you use to measure the ATP levels in fluid, and I'm not going to get into that too much because I don't want to spill the beans, but we will be sharing here probably a couple months down the road. We're going to have a webinar demonstrating some new equipment showing how you can actually measure the soil load in water using an ATP meter.
Great, and we actually got that question, so I'm glad you were able to address it. I know you talked a little bit about ATP, using an ATP meter in a few places. Could you just briefly define ATP and its use in the testing methods for residential cleaning?
Okay, ATP stands for adenosine triphosphate. It is the energy molecule in all organic cells, and you often find it in conjunction with soil, especially organic soil. So the thinking is, and this is being elaborated by more and more studies, that there is a correlation between the amount of bacteria in soil with your ATP reading. And so if you get a really high ATP reading, that means there's a whole lot of soil and a whole lot of nasty germs on the surface.
But I guess the thing that you don't always know is what, you know, if you have a high ATP reading, there may or may not be something there that's harmful to you. But we use it to make sure that we have a low ATP reading, because if you have a low ATP reading, you can be confident that it is a
that you've cleaned it well. Yeah, that you've cleaned it well and it's a safe surface.
Well, great. Yeah, there was some confusion in the questions about testing, you know, ATP on dry, hard surfaces versus in water. So that's I'm sure that helps folks. Continuing a little bit in this same vein, how do you know that deionized water is not a sanitizer or disinfectant?
A couple of ways. First of all, if we're going to claim it's a sanitizer or a disinfectant, or if anybody's going to claim that at all about a product, it must be tested and approved by the EPA to have such a claim made by it, which is a problem where some people put out on whatever product they happen to say and say it's a sanitizer. Sanitizer or disinfectant refers to the ability to actually kill germs. What we're doing with this and a good microfiber cloth is we're removing germs.
Right, exactly.
So we are sanitizing, but we are not killing. And so we can't claim it to be a sanitizer, which has a very specific legal meaning, and as I say, must be approved by the EPA, and or a disinfectant, which has another specific legal meaning. And EPA does not have a lot of sense of humor about messing around with their approvals and such on that.
But it's kind of interesting if you use your favorite sanitizing cleaner and whatever typical wipe you're using and compare it to DI water and a quality microfiber wipe, measure with an ATP meter, you're very likely to see that you're getting a lower ATP level with the DI water and the microfiber wipe.
Right, because you're doing a better job of removing your
right. And as we have said before, it's most people who are going out there and claiming to disinfect aren't. They're just wiping it down with a relatively ineffective cleaner that is disinfecting some stuff on their cloth, maybe.
Mm-hmm.
We've mentioned a couple of times, several times through our presentation about the DI kit, and this is something that we've assembled at Modern Cleaning to make it really easy for any professional house cleaning service to implement DI water in their business as a general purpose window cleaner. This kit has a number of different components in it. I guess let's start with step-by-step procedures in terms of how to assemble the kit and how to use it and how to make your DI water. That's what we're looking at here. These procedures are stored on this DVD that also have a number of other pieces of useful resource information, not least of which some video that we've recorded. It's video that actually we also use from our School of Cleaning CFC instructor training that you'll find very useful in terms of how to clean with it and the various things you can do with it. The kit obviously would need the DI tube. Inside of this tube is a replacement cartridge that will keep you going for at least 300 gallons. You've got a hose here, which is an input tube. You've got the outlet tube here. There's no exposed metal or anything here on this tube just to make sure that you're keeping your DI water pure. The water would actually be coming out of the back side here. You can't really see it, but here's the TDS meter that's reading constant flow. Here's a second TDS meter that's handheld that you can use to test your water. Here's a 5-gallon buddy jug, and the kit comes with 6 pre-labeled bottles. And you can buy this on our website through Modern Cleaning immediately after the presentation. If you go to Modern Cleaning, you can go to the engineered water section in our store, and you'll see the kit displayed there. It's got a price of $3.97, but that's everything you need to get started, and that includes shipping. So it's a big box of everything you need, and at that point, well, I'm getting to that.
Okay, sorry.
At that point, you're in business, and depending on how hard your water is, every 300 gallons plus, you'll wind up getting another cartridge to put in it. But for the most part, and the cool part about this is, compared to some of the other things that we've looked at in the past, one of these will work for your entire business, whether you've got cleaning by yourself, or if you've got 50 technicians out there cleaning, you can staff all of them with just this one investment.
And that's great, Tom. I've got a question about the kit, if you don't mind me breaking in. With the labels on the bottles and the jug, do they meet OSHA requirements? And I think it says GHS. I'm going to guess that means something like General Health Safety Standards, something of that nature. I'm not familiar with GHS, but
I'm not sure that they meet what OSHA told me that we needed.
Actually, I don't even think OSHA had a position that anything was required.
No, they just strongly recommended that it be labeled. And I just looked around and saw what labs and industries were doing, and I kind of created our label based on the information they had on theirs.
Well, what do the labels include? What information is included on them? That may be helpful to the folks who are asking.
Health effects, precautions, what type of PPE to use when dealing with deionized water. So
I mean, it's the typical precautions you would find on any label, and they're very few because it's benign. It tells you don't drink it.
Right.
But if you get it in your eyes, you really don't have to worry about it. If you get it on your skin, I mean, it's about as benign as you can get.
Yes.
Okay, thanks for that. That was the only question we got about that. Oh, nope, sorry, got another one. We see the kit on the screen. Do we also sell just the bottles?
We will be. As it stands at this instant, we don't have that up on the store, but I imagine here over the next week or so we'll probably be expanding this out and offering some of this a la carte but we're really hoping for the moment that people will see the value in getting started with the entire kit. Because a lot of what really creates the value of the kit is the instructions, procedures, and videos that you're getting down here on the DVD.
It's nice to have the correct hoses too. We went slightly crazy trying to figure out what the output hose should be like.
Yeah, this is kind of trial and error. We've actually sold a number of these, even though we really haven't been promoting them hard, and we kept getting feedback about how do you hook it up and where do you get your hoses, this and that, so we figured we'd just make it easy and get everything you need and put it in one box.
Yeah, if you have the wrong kind of output hose, it doesn't work, and it drives you slightly crazy. You keep going, what am I doing wrong?
And as part of this promotion, if you order a kit by the end of January 31st, starting today, and I guess through the end of this month, we're going to include a free starter kit of Perfect Clean wipes. The 4 blue wipes, 2 orange wipes, and the green wipes are, the blue and the orange are terry cloth, general purpose cleaning. Terry cloth. Did I say terry cloth?
Yes, you did.
Oh, okay.
They're cleaning.
They're cleaning, but
cleaning
they're of a terry cloth design as opposed to the green wiper, which is smooth and is designed for polishing.
Okay.
Okay. Blue would be for your general purpose cleaning. Orange would be color coded for cleaning your bathrooms. And green is great for polishing chrome and cleaning mirrors and windows. And the kit, including this, if you order by the end of the month, would be, including shipping, is $397 and change. $397.24. Wow. Am I missing anything, Janice? Anything else you want to correct me on?
No, but I wish I'd had that kit.
You'll save that until after we're done? Okay.
I would have. It would have saved me a lot of running around.
Any other questions, Cece?
I did have one about recharging the pellets. Is that possible? And if so, how much that costs?
Don't know necessarily about recharging the pellets. Theoretically, you can do you can backwash and reduce your TDS level. The risk that you're taking with that, and we talked about this earlier, was do you have any type of organic matter growing inside of it? So it's probably a good practice just to go ahead and replace with a new cartridge when your level starts going up.
All right.
On our website, on our Modern Cleaning website, there is a section for webinars, and if you want to watch this again, this will be available, I imagine, the next day or so. We'll have this up that we can go back and see it again. We have past events there as well. Got a number of webinars that we've been doing over the last year. Got some other events that are coming up through ISE that Cece, you might want to share a little bit about.
Thanks, Tom. Yes, we're wrapping up today. Again, want to thank everybody for joining ISE as we sponsor this Modern Cleaning webinar. ISE has a couple of, or actually a trio, not a couple, a trio of weekly webinars coming up next week, next Wednesday at 1, next Wednesday at 4 Eastern. Derek Christian's going to share 10 ideas to grow your business. Now, we know Derek primarily as a marketing expert, and he is usually really great to share ideas that you literally can with the moment the webinar ends, you can write it up and you can do it in an hour. At least one of his ideas you'll be able to do that with. He's really good to include that. A week later, January 30th, Tom is going to share some of his costliest mistakes, things he didn't know that he had to learn by experience. But it's some of the things that people you just never hear about. Just those little things you just never hear about until it happens to you. And then as I mentioned earlier, for the folks who joined us early, February 6th for the regular First Wednesday at 1 webinar, Bruce is going to share the 5 stages of growth for a cleaning business. This is actually going to be sort of a repeat of a class he teaches as part of our Foundations of Business program, but it was so incredible. I begged him and the other partners to let us put it out there for everybody, because it's just a fantastic way to understand and to think about, you know, where you are in your business and where you want to go, and you know, give you goals and steps to you know, to take to, you know, get to the next level that you're looking for in your business. But it was just the perfect way to see what your business was doing. So that's what we've got coming up, and certainly in February we are starting our 2013 series of HCT classes, and the first one in February is going to be in Charleston, South Carolina. Now, who can give that up? Come on, that's in the early, right in the middle of winter. You want to come to sunny South Carolina? Come on, you got to come on over. You can see the ocean and get your certification at the same time. It's a fantastic opportunity. It's the first time Castle Keepers has hosted the HCT class, and they've got a fantastic setup. So it's worth it just for the tour of the facility. So that's the stuff we've got going on. We do have a new series of Foundations of Business starting in February as well. So if you're looking for a solid and comprehensive business growth and development program, give us a call and we'll tell you all about it. So that's what we've got coming up. But
cool.
I haven't seen any more questions. So that's all the ISE announcement we've got is to sponsor today's webinar. Tom, Janice, Bruce, any final comments or thoughts?
Appreciate everybody joining us today, and you know, the questions don't have to stop here. This is the fun part about it. You can easily reach us through email. Our ISE has a LinkedIn group that we share information like this as well. So just reach out if you have any questions, and we'll keep the discussion going.
Always. Wonderful to keep that going. Thank you so much, guys, and thank you, everybody, for joining us today.
Thank you, everybody.
Thank you, everybody. Bye-bye.